Hello, this is the TI-84 guy. I am working with one of my students who is going to be taking the SAT at the end of August. And this past weekend, we were working with practice test number 9, the SAT practice test number 9. And one of the things that I realized is that almost half of the questions on the calculator section could be answered using my ALINEAR program, which I thought was actually pretty phenomenal. In fact, out of the 38 questions from that section, 18 of them I could use the program on. So what I decided to do is I said, why not create a video that shows students how they can use the ALINEAR program as much as they want to on these kinds of questions. So that's what this video is going to be about. Now, I'm going to say this up front. A lot of the questions that I'm going to go over, you don't absolutely need a program. You can do it without a program, or there's a bunch of different ways to do it. But what I want to do is I want to show you how you would use the ALINEAR program if you wanted to, and give you that option. Okay, so what I'm going to do is I'm going to go over 19 questions. They're going to be 18 from the calculator section of practice test number 9, and there's going to be 1 from the non-calculator section. And I'll explain why I'm including 1 non-calculator question as well when we get to that. And this is going to be a longer video because I'm going to go through all 19 questions and show you how to use the program. But I'm also going to include the timestamps for each question. So if you want to go to a particular question from the practice test 9 and see how I do it, you can skip forward, skip around. All right. Now, having said that, I think it's really valuable if you watch this video from start to finish with your graphing calculator by your side, and hopefully you have a copy of my program, ALINEAR, on your calculator so you can see how I use it so that you can learn how to use it. I think that's the best thing that you can do to prepare and learn how to use the program. I'm also going to include in the link, in the section below, a link to the practice test number 9 so that you can follow along with me as well. Okay, now, so I'm going to jump into this because this is definitely going to go a little longer than my normal videos because I'm going to be doing about 19 questions. All right, so let's go. First, all right, so here are the first 4 questions. And out of the first 4 questions, 3 of them you can use the ALINEAR program on. Now, again, it doesn't mean that you have to, but I want to show you how you could if you wanted to. So the very first question, it says, what value of x satisfies the equation 3x plus 3 equals 27? So I'm going to go to my program. You would press the program. It's the very first one called ALINEAR. Press enter again. And in this case, we're going to use a system of equations. The left-hand side of the equation is in y-intercept format. So the slope is 3. The b term, the y-intercept is 3. And then the right-hand side of the equation is also in y-intercept form, but the slope is 0 because there's no x term, and the y-intercept is 27. Enter that, and when you press enter, it tells you that the x value is 8. So the answer for this question is 8, and that's what you circle and keep it moving. 8. Now, next one, number 2, it says 2 units of length used in ancient Egypt were cubits and palms, where 1 cubit is equivalent to 7 palms. So it says the Great Sphinx statue in Giza is approximately 140 cubits long. Which of the following best approximates the length in palms of the Great Sphinx? Okay, so this is a proportion. So it's a linear equation. So I would go here, I'd use the program again, I'd press enter, and I would use option 4 for proportion. So here I would say 1 cubit is equal to 7 palms. So 140 cubits is equal to x. That's what we're trying to solve. And that means it would be 980. So I would go here and I would circle 980. Now, one thing. Whenever you have a conversion, 1 cubit is equal to 7 palms, you're almost always going to be using a proportion, which means you can use the ALINEAR program. So this would be Number 4, proportion. This one is 5 for system of equations. Okay, and now let's go to number 3. Number 3, it says if 2n divided by 5 is equal to 10, what is the value of 2n minus 1? All right, so again, this is a linear equation. So I'm going to go to my calculator again. Excuse me. And I'm going to press enter. I'm going to use the system of equations again. The y-intercept for this one is 2/5. And the y-intercept is 0. And then on the other side is also the y-intercept, and the slope is 0, and the y-intercept is 10. So once you do that, it tells you that the x value is 25. Now, we don't want the x value. What we actually want is 2x minus 1. And this program stores the answer, the coordinate for the answer for x in the x variable, so you can use that. So the answer for this one would be 49. And this is also system of equation. All right. Number 4 is not a linear function, so we can't use ALINEAR. So we'll just go to the next page. All right, so no. Number 5, 6, and 7 were not linear problems, so we can't use the ALINEAR program. But number 8 is definitely a linear. It's a line, it's a graph of a line. And what they want you to do is they want you to find out what is the cost for each additional mile traveled. So basically what they're asking for is the slope. Now, the way that most of you would do this or should do this is you should use rise over run. So right here, this is 0, 3, and this is 1, 5. So if you go up, you've gone up 2. So the rise would be 2, the run would be 1. So the slope is 2 over 1. So it would be choice A. Now, but you could, if you wanted to, you could also use the ALINEAR program. So in this case, we press enter. Actually, we press program and then enter again. And this time we're going to use option 1 for 2 points. And the 2 points were 0, 3, and then 1 and 5. And then all you're going to do is you're going to find the equation. It's going to give you the slope, and it tells you the slope is 2. That's your answer, okay? So for this one, you could use 2 points, okay? Now, number 9 is not a linear problem, so we can't do that with the ALINEAR program, so let's keep going. So the next question, let me change my iPad around so that this orientation switches. It says, why should in high school randomly selected freshmen, sophomore, junior, and senior students for a survey about potential changes to next year's schedule? Of the students selected for the survey, 1/4 were freshmen, 1/3 were sophomores, and then half of the remaining students were juniors. Okay, if 330 students were selected for the survey, how many were seniors? Now, so I'm going to show you how to use the ALINEAR program, but I would not use the ALINEAR program for this. I would use something called a ratio box, and I'll show you how I would do this. So this will be freshmen, this will be sophomores, this will be juniors, this will be seniors, and then this will be our total. Okay, so here's what we're going to do. We're going to put in, so we had 1/4 of them were freshmen, 1/3 were sophomores, and then that means if you add these two together, that's going to be 7/12. So that means that we have 5/12 remaining for the juniors and seniors, and they were split in half. So that means that the number of juniors would be 5 over 24, and also the number of seniors would be 5 over 24. If you add all of these going across, you should get 1. If you total all of these, you should get 1. Now, they tell us that the total number of students that were surveyed were 336. So that's what goes down in the bottom here. And what you want to do with the ratio box is you want to find out what number do you multiply 1 by to get 336, and it's obvious that it's 336. So this is called the multiplier. And everything in this table gets multiplied by 336. Every fraction. So if you multiply 5/24 times 336, that'll tell you the number of seniors that we have. And there's going to be 70, which means there's going to be 70 juniors. If you do 1/3 times 336, that's going to be 112. If you do 1/4 times that, that's going to be, let's see, it's going to be 84. Now, if you go across and add these, they should total up to 336. But the answer for this one would be 70. Now, since these are proportions, you can also use the ALINEAR. So I'm going to show you, even though I would use the ratio box, I'm going to show you how you could use the ALINEAR program. We're going to go over, click this, press enter, and we're going to use option 4. And here's what I'm going to do. I'm going to say, this is going to be the fraction of seniors. So what I'm going to do is I'm going to go subtract. I'm going to subtract the fractions from 1. So it's going to be minus 1/4, which were freshmen. And then I'm going to subtract 1/3, which were sophomores. And then I'm going to take half of this. I'm going to multiply it times 0.5. So that's going to give me the number that are the fraction of seniors. And then I press enter, and that's over the whole, which is 1. And then my next one is going to be, I want to find out how many are actually seniors. And then out of the total of 336. So when I do this, it tells me that X, the number of seniors, is going to be 70, which is what we saw. So you could definitely use ALINEAR to do this. I would actually use the ratio box, but if you wanted to, you could use the ALINEAR program. All right, let me keep it moving. So let's go back to my test. All right, number 11. So this one would be option 4 for proportions. So I'm just going to write that on here. All right, and so number 11, it says, plant A is currently 20 centimeters tall, and plant B is currently 12 centimeters tall. The ratio of the heights of plant A to plant B is equal to the ratio of the heights of plant C to plant D. If plant C is 54 centimeters tall, what is the height of plant D in centimeters? So this is basically a proportion. They're saying A to B is equal to C to D. And all we have to do is replace it. So it's 20 over 12 equals 54 over X. I would go straight to my calculator on this one. And I would go here, I press enter, option 4. And then I'd put in 20. I'd put in 12. I'd put in 54. And then I put in X. And it's going to solve it for us. Boom. It says 32.4 is my answer. So I go over back to my test, look at the answer choices, and that would be choice A, 32.4. So this is for proportions. By the way, there are a lot of proportions on the SAT. That's one of the favorite types of problems. All right, so let's keep going. All right, this is number 12. It said a biologist found a new species of pale shrimp at the world's deepest undersea vent, the BB Vent Field. The vent is 3.1 miles below the surface of the sea. Approximately how many kilometers below the sea surface is the vent? And then they give you this conversion. 1 kilometer is equal to 0.6214 miles. Anytime you see a conversion, that usually means that you're going to use a proportion to solve it. You may have to do something else, but you're definitely going to need a proportion to solve it, to convert, all right? So, but whenever you see this, you can always use the ALINEAR program. So we're going to go back, and we're going to do basically the same thing we just did from the last problem. So it's going to be enter. We're going to choose option 4. So I'm going to say 1 kilometer is equal to 0.6214 miles. So how many kilometers, I'll put an X there, is equal to 3.1 miles? And you just say 3.1, press enter. Boom, it says 4.98. All right, so if we go and look at the answers, we're looking for, it says approximately, so 4.98, we round that up to 5, and our answer would be D. And we keep going. So this is option 4 for proportions. Okay, now let's go to number 13. Excuse me. It says a cargo helicopter delivers only 100-pound packages and 120-pound packages. For each delivery trip, the helicopter must carry at least 10 packages, and the total weight of the packages can be at most 1,100 pounds. What is the maximum number of 120 packages that the helicopter can carry per trip? All right, so this is a system of linear inequalities, and it's an inequality because it says at least and at most. So here we go. So X stands for the number of 100-pound packages, 100 pound, and Y stands for the number of 120-pound packages. All right, so here's going to be our two equations. One is going to be X plus Y has to be at least 10, so it's got to be greater than or equal to 10. And then our next equation is going to be 100X plus 120Y is no greater than 1,100. Now, so we got a system of linear inequalities, so we can go to a linear. Press enter. We're going to choose option 5 for this one. And they are both in standard form, so we're going to choose option 2, and it's going to be 1 coefficient of the Y term is also 1. The constant is 10 because it can't be greater than 10 packages. And then we're going to use the standard again, and it's going to say 100-pound packages and 120-pound packages, and it can be no more than 1,100. So we're going to put 1,100 here, press enter, and it tells us that the intersection occurs at 5,5, which means that we can have no more than 5 120-pound packages. That would be our answer. So if we go back over to the test, it would be choice C. All right, so this would be systems of equations. All right, so let's keep going. Now, number 14. Number 14 and 15. These are basically the same type of question. One is a word problem, one gives you some coordinates, but they're essentially the same question. So let's read it. It says a company purchased a machine valued at $120,000. The value of the machine depreciates by the same amount each year, so that after 10 years, the value will be $30,000. Which of the following equations gives the value V of the machine in dollars T years after it was purchased for T being between 0 and 10? So this is a linear equation, and the reason that we know it is one, all of the answers are linear equations, but also because it says it decreased by the same amount each year. So it's going down by the same amount. So it's a linear function. Now, in order to come up with an equation, we need 2 points. So this is going to be V, this is going to be T, and this is going to be V. So T, at the beginning, the machine cost $120,000. And then after 10 years, it depreciated down to $30,000. So we've got 2 points. So, and it's linear, so we're going to go to A linear. We're going to press enter, bam, and we're going to use option 1, 2 points. And then we're going to go 0, 120,000, 1, 2, 3, 4, and then we go 10 years later, it was only 30,000. 1, 2, 3, 4, and then press enter, and we want the equation. So we choose option 1, and we want it in slope-intercept form, so we choose 1. Tells you that the slope is negative 9,000, and the y-intercept is 120,000. If we go over to our answer choices, it would be answer choice B. Okay, got it? So this is option number 1, 2 points. Now, if you go down to 15, it's the exact same question, except that instead of us coming up with the 2 points from the word problem, they just give us the 2 points. So all we're going to do is we're going to enter that. Now, before we go into this, if you look at this point right here, it says that one of the points is 0, 1. If you're on top of your game, you should know that that's going to be the y-intercept. And because that's the y-intercept, you should just go down to your answer choices and look to see which one has 1 as your y-intercept. And it would be D. So technically, you don't have to do anything else for this problem if you realize that. Unfortunately, some students might not see that. And if you don't, just go to the program and enter your 2 points. It may take you a little bit longer, but you'll still get this one right. So let's see here. So the 2 points, we press enter, and it's 2 points again. So it's going to be 2, 4, 2, 4, and then 0, 1. Press enter, we want the equation, and it tells us that the slope is 3/2, and as we expected, the y-intercept is 1. If we go back to the answers, it's going to be D like we expected, okay? So this is 2 points. And if you're on top of your game, you don't need the program. But if you're not on top of your game, let's say you're not, for some reason, you're not as sharp as you normally would be, you can still use it using the ALINEAR program. Option 2. All right, let's go. All right, so number 16 is not a linear function. 17, it says 2w plus 4t equals 14. 4w plus 5t equals 25. What is the value of 2w plus 3t? All right, so this is basically, these are 2 linear equations. So what we have here is a system of linear equations. So I would go back to the program, ALINEAR, and press enter. And for this one, I'm going to choose option 5. And then both of those equations are in standard form. So we put 2, and the coefficient was 2, enter, and 4. And then 14 was the constant. And then the other equation was also in standard form. The coefficient for the x term is 4, the coefficient for the y term is 5, and the constant is 25. 25. Enter. And it tells us x is 5, y is 1. But we don't want the intersection. What we want is 2x plus 3y. So since these values are stored in the x and y variable, all we have to do is just use them. 2x plus 3y. Alpha 1 gives us the y variable. Press enter. Tells us that the answer is 13. So we would go over here. And the answer is C, 13. So this would be 5. System of equations. All right, let's keep going. All right, this one, I'm going to turn it this way. All right, so here we go. It says, now this is one of those questions where you're going to be using this information for multiple questions. So it's 18 to 20. Number 19 or number 18 is actually, it's kind of a linear equation, but you really shouldn't use the ALINEAR program because it has a bunch of variables in it. But this one, number 19, is definitely one where you can use the ALINEAR program. So let's do this first and read this portion, and then we're going to look at the actual question. So it says, Jennifer bought a box of crunchy grain cereal. The nutrition facts on the box state that a serving size of the cereal is 3/4 cup and provides 210 calories. 50 of the calories are from fat. That's a lot of fat. In addition, each serving of the cereal provides 180 milligrams of potassium, which represents 5% of the daily allowance. So those are the facts. 3/4 cups gives you 210 calories. Now, if we look at problem number 19, I'm going to change it, use blue. It says, on Tuesday, Jennifer will mix crunchy grain cereal with super grain cereal for her breakfast. Super grain cereal provides 240 calories per cup. If the total number of calories in 1 cup of the mixture is 270, how much super grain cereal is in 1 cup of the mixture? So we are mixing super grain with crunchy grain, and we want to know how much we should mix of each to get a mixture that is 270 calories. So here's what I'm going to do. I'm going to say X is the amount of crunchy grain, all right, and Y is the amount of super grain. And here's what we have. So x plus y equals 1 cup. That's one equation. Now, the second equation is a little tricky. We've got to put this in a per cup, a unit rate of per cups. Right now, this says 3/4 cups gives you 210 calories. We want it as a unit rate per cup. So what we're going to do, what I'm going to do, is I'm going to take 210 calories and divide it by 3/4 and multiply that times x, because that's going to be the serving per cup for the crunchy grain. And then I'm going to use the 240 calories per cup for y, and that's going to equal 270 calories. So this is the unit rate for the crunchy grain cereal. This is the unit rate for the super grain cereal, and this is going to be the total calories. So now, this is a system of equations, so we would just go back to ALINEAR, press enter, option, actually we got to go program now, boom, and we're going to use option 5. Both of the equations are in standard form, so it's one super crunchy grain plus one super grain equals 1 cup. That's one equation. Second one is also in standard form. Now this one is tricky, so let me watch how I do this. This is 210 divided by, and I'm going to use parentheses, 3/4. All right, so this gives me the unit rate for the crunchy grain per cup. And this is 240 for the super grain. And the total was 270. And I press enter. And it tells me that the crunchy grain is 75% of the cereal, and that the super grain is 25%, which is 1/4. So if I go back over to the test, the answer choice would be answer choice B. Okay, that's it. So the option for this one, once you come up with the equations, would be option 5, system of equations. System of equations. All right, let's keep going. All right, this was also connected to this one, okay? So it says, which of the following could be the graph of the number of calories from fat in the crunchy grain cereal as a function of the number of 3/4 cups of cereal, right? So it said, so we're graphing the number of calories from fat. Okay, so this is saying the number of calories of servings. So we know that if there's 0 servings, we have 0 calories from fat. We have 0 calories. And we also know that if we get 1 serving of crunchy grain cereal, that's going to be 50 calories from fat. So here is what we got here. So it's 0, 0, and then we got one serving. 1 serving will give us 50 calories. So all we're going to do is, I'm just going to show you, you don't really need the program on this, but you can use it. We're going to use 2 points. It's going to be 2 points. It's going to be 0, 0. And then we're going to have 1 serving. We have 50 calories from fat. And that's the equation of a line. We want it in slope-intercept form. And then we're just going to graph it because the program put this in, the ALINEAR program put this into Y1. So if we want to, we can graph it now. So we're going to go zoom 6, see what it looks like. All right, it's hard to tell here, so I'm going to do zoom 0 because I want you to see. Now that's what it looks like. You can see that it's clearly going through the origin, which is what you expect because 0, 0 is the origin. But if you look at the actual choices, there's only one that's going through the origin, so it would be A, okay? We graphed it. It looks like this one. So that's our answer choice. Now, on this one, you didn't absolutely need the ALINEAR program, but if you wanted to verify what it looks like, you could have graphed it and see, and just to double check it. So the answer for this one is A. All right, let's keep going. All right, so now, this question here, number, I think this is 29, and I believe this is 30. Let me see. it might be 30, 31. I actually forgot to put the numbers on here. But it says this one is actually a linear equation, but you don't really need the ALINEAR program for this one because they've already kind of given the equation, and they're just asking you to interpret what's the increase in the minimum wage over the 70-year period. So basically, they've given you this equation, and they want you to interpret it. So it really doesn't, the ALINEAR program is not going to help you interpret anything. So what you should do in this particular case, if I were you, is I would just graph this. And I would look at, okay, what happens every year? Because the choices are, the two choices that you really have to choose from, it says each year between 1940 and 2010, the average increase in the minimum wage was about 9.5 cents. That's what this one says. So 1 year, every year, it goes up by 9.5 cents. This one is not right. C is another choice. It says every 10 years between 1940 and 2010, the average increase in minimum wage was 9.5 cents. Now, so basically you have two choices and you have to decide which one do you think it actually is. What I would do, if I'm not sure, I would actually go to Y and I would graph it. Or I'd enter the equation. So this would be 0.096 x minus 0.488. And here's the key thing for me. What I want to see is I want to see what happens every year, and I want to see what happens every 10 years. So what I would do is I would go to my window, and I would set this independent variable to ask, and then I would go look at my table. All right, let me get rid of all of this stuff so I can show you exactly what I want to do. I would say in 1 year, let's say it would be a negative 39 cents. If I increase it by 1 year, what happens? It looks like it's going up by about 10 cents. It's going up by about 10 cents. All right, now I'm going to jump from 1 year to 11 years, and I want to see what happens there. So look, it goes from a negative 39 cents to about 57 cents. So that is about 40, that's about 96 cents. 96 cents difference in 10 years. It went up by about 96 cents. And if we go back to the answer choices, this one said each year it went up by about 9.5 cents, and it actually did go up by about 9.5 cents. This one says every 10 years it goes up by 9 cents. That's not true. It went up by 96 cents, so it's not this one. So our answer choice would be A. So the ALINEAR program wasn't really helpful for this one, but if I were you, I would actually graph this. If you don't know what the slope is, if you don't know how to interpret the slope, go look at the slope and see what happens every year when you increase it. So let's go to the next one. Now this one is another scatter plot. But in this particular case, they did not give us the equation. They want us to come up with the equation. You can see they've given us a bunch of linear choices. So here's what I would do. I'm gonna cheat a little bit since I have this. I am going to extend this line. That's not a very good. Let me see if I can do this a little better. Okay, let's say that. So I would say. Actually, let me do one more thing. I'm going to make this a little thinner. So now let's see what we can do here. Bam. Okay, that's a little better. It's not perfect. I'm trying to get that to match, and this is hard. Okay, so let's just use that. So I extended the line. So one of the points that I'm going to use is here. And let's go find another point that's good. Here's another point that's good. So what I'm going to do is x, y. I'm going to say x is 10. The y value looks like it's about, let's say 410. And then I go over here to 20, and I go up, and I say that's about 740. Maybe 745. It doesn't have to be exact, I don't think. So now I'm going to go to ALINEAR, And I am going to, let's see, I'm going to press enter. I'm going to use 2 points. That's all you need to come up with a linear line. So I'm going to say 10 and 410. And then I'm going to say, I'm going to enter 20 and then about 740. And then I want the equation in slope-intercept form. So it says the slope is 33, the y-intercept is 80. So let me write that down. So y equals 33x plus 80. Now let's go look at the answer choices and see which one we got here. All right, so let's see. Okay, these are too low for slopes. Both of these have 33, but the y-intercept is way too high for C. This one is definitely the closer one. So using 2 points, this point, kind of guesstimating, came up with this, and I was able to get this equation. So this would be 2 points. All right, so there you go again, another question that we were able to answer. Let me switch my iPad so we can get this oriented. Now, this is a number 32 question. It says in the XY plane, line L has the y-intercept of a negative 13. And then it says, and that line is perpendicular to this line with the equation y equals a negative 2/3 x. If the point 10b is on the line L, what is the value of b? So basically what we're going to do is we're trying to come up with an equation of a line that's perpendicular to this. And we want to know when the input to that linear function is 10, what's the output going to be? Okay, so here's what I would do. First thing, since this is perpendicular, we know that the negative reciprocal is going to be the slope for this line, for line L. You've got to know that fact. If you don't, this question is impossible to answer. So we know that the slope is 3/2, but we also know that it has a y-intercept of a negative 13. So it's going through this point. So now that I have that, I can go over to ALINEAR and I can figure out everything else I need. So I press enter. And I'm going to use option 3 because I know a point and I also know the slope. So I choose 3, and the point, the coordinates are 0 and a negative 13. And the slope is 3/2, a positive 3/2, and a negative reciprocal of the other line. And then we want to know when x is 10, what's the y variable going to be, or y coordinate? So I'm going to choose option 2, and it's going to say, okay, give me the x value that you know, and we're going to enter 10. So we're going to 10, boom, press enter, and it tells us that the y value is going to be 2. So if we go back over here to the answer sheet, it's going to tell us that b is equal to 2. And the option that we use for this one, option 3, a point and the slope. Now, let me stop before I go further. I've been working for about 30 minutes, and I've got a couple more questions I want to do. Before I do the next question, I have to tell you, this question here came from the non-calculator section of the practice test 9. So this is number 20. So there are 20 questions in the non-calculator section. So this is the very last question on the non-calculator section. Now, here's what I would say, and you guys take it however you want. If I were doing this question, number 20, so that means I'm at the very end of the test, and I don't have a calculator. But as I look at this problem, I say like, wow, man, this is a linear equation. And if I had my program, the ALINEAR program, I could answer this pretty easy. Now, but you don't have it. But you will have it probably in a little bit. So if you can remember some of your details, why not answer it when you get the calculator? That's just a thought. You don't have to. That's just how I'm kind of looking at it. So if you look at this question and you don't know how to figure it out kind of without your calculator, you should say, well, this is the last question of the section. I'm going to the calculator section. I'm going to have my program ALINEAR. Let me see what I would do. because this problem right here is almost identical to the one up here. All right, so let's read it and let's do it. It says the graph of a linear function f is shown in the xy plane above. The graph of the linear function g, which is not shown, is perpendicular to the graph of f and passes through the point 1, 3. What is the value of g sub 0? So I'm going to make this red, and I'm going to make this a little thicker. All right, so here is point 1, 3, and we're going to go through this, and it has to be perpendicular. There, that's not bad. Maybe a little low, but that's not bad. So this is perpendicular to this line, and it goes to the point 1, 3. That's what we're trying to find. This is going to be g. And we want to know what's g sub 0. So basically what we're trying to find is the y-intercept. Okay, so here we go. So what we're going to do is we got to figure out the slope of f. So here's a point, and here's a point. So if we go down 2 and we go over 1, that means the slope is a -2, which means that this slope is a negative reciprocal. So this is going to be 1/2, a positive 1/2. That's the slope of this line. Okay, now that we have this point and this slope, we can do the same thing that we just did for the last question. Go to the calculator, press enter, choose option 3. The point that we have is 1, 3. 1, 3. The slope is 1/2. And we want, there's a couple ways that we could do this. We could just say, okay, we just want the y-intercept. So the y-intercept is 5/2. So, or 2.5. And by the way, whenever you run this program, it also will calculate and put the equation here. So you could either grid in 2.5 or you can grid in 5/2, whichever one you want to do. So let's go back over here. Share my, okay, so the answer for this is you can put 5/2 or 2.5. And the option that we would use would be option 3. Now, I'm going to say this one more time. This is in the non-calculator section. So you don't technically have your calculator available, but if you remember these little details, when you get your calculator, you can go ahead and plug them in anyway and answer and then grid it in. Not saying that you should, I'm just saying that you could. All right, so that's it. Let me keep going. Now, this is number 33. I think we got like maybe 2 more questions on here. So this is a table of values for blood types. So it says, human blood can be classified into 4 common blood types, A, B, AB, and O, and is also characterized by the presence of a plus or a minus of the rhesus factor. The table above shows the distribution of blood types and the rhesus factor for a group of people. If one of these people who is rhesus negative is chosen at random, so we're going to be choosing from this group of people, okay? And it says the probability that the person has a blood type B is 1/9. So they say if we choose from this group of people, the probability that they have a blood type of B is 1/9. So here's what we're going to do. This is basically a proportion. But here's what we need to do. It's going to be the probability of choosing a person who has a blood type B is 1/9. But in actuality, we have 2 people out of the total. So what's the total number of people that we have? It would be 7 plus 2 plus 1 plus X. So this is the equation that we would enter. So let's go. We're going over to the calculator again. We're going to press enter. We're going to use option 4. We're going to put in 1 out of every 9 people who have the rhesus negative factor. And then there were actually 2 people out of a total of 7 plus 2 plus 1 plus X. Press enter. And it says that X is 8. So that means when we go back over here to we would grid in 8 for X. And this would be option 4 for proportions. All right, let's keep going. So it can handle probabilities. Here we go. It says Gisela would owe $15,500 in taxes each year if she were not eligible for any tax deductions. This year, Gisela is eligible for tax deductions that reduce the amount of taxes she owes by $2,325. If these tax deductions reduce the taxes Gisela owes this year by D%, what is the value of D? All right, so here's what we're basically doing. This is another proportion. So they're saying she reduced her taxes this year by $2,325, and she would have paid $15,500 if she didn't get that reduction. And they want to know what percent reduction does this represent. So this would just be D over 100. Here's our proportion. So let's go back to the calculator. Bam, boom, press enter. Option 4, this is 2,325. Press enter. This would be 1,500, 500. And then this would be X, and this would be 100. And when we press enter, it tells us that the percent decrease is 15%. And so we would go over here, and we would say D is 15. Grid it in, keep it moving, let's go. This is the last question. Let me turn this way. This is number 38, last question. Usually they go in difficulty, so this is considered kind of a difficult question, relatively speaking. So let's read this. It says the table above shows the number of international tourist arrivals, and it's rounded to the nearest 10th of a million. And this is the table that represents the top 9 tourist destinations in 2012 and 2013. Okay, so they gave us those 2. So now we're going to be using that information for number 38. It says the number of international tourist arrivals in Russia in 2012 was 13.5% greater than in 2011. The number of international tourist arrivals in Russia was K million more than in 2012. Well, let me say that again. The number of international tourist arrivals in Russia was K million more in 2012 than in 2011. What is the value of K to the nearest integer? I'm going to change colors here. All right, so what are we looking for? What we're looking for is we're going to be using Russia. We're going to be using this number right here. Russia in 2012 was 24.7 million. We don't know what 2011 is. That's what we're going to have to figure out. And then we're going to take the difference to answer our question. So here's something that you should know. If from 2011 to 2012, it went up by 13.5%, here's what you can say. 2012 divided by the number in 2011 equals 1.135, all right? So this represents a 13.5% increase, right? So when you divide the number that you have in 2012 by the number that you have in 2011, it should go up by 13.5%, and that's what this says. So this could be a proportion as well. So let's just fill in what we need, what we know. So we know in 2012 there was 24.7 million. We're trying to find how many were in 2011, but we know this is true right here. So all we would do for the, I don't know how many times we've used this feature, proportion, we could press enter, we could do proportion, we can go 24.7 over X, that's 2011, equals 1.135 over 1, and then we go enter, and it says that in 2011 there were 21.8 million people who entered Russia. So let's go back to our answer sheet. And so all we would do is we would go 24.7 minus 21.8. So this would be 9. This would be 2.9. They said rounded to the nearest integer. So this would be 3 million. That would be my answer. So K equals 3. We use the proportion piece of the ALINEAR program. Proportion. All right, we use this a lot. Okay, guys, that's it. How much time did this take me? Let me see what I got. Oh, 46 minutes. Okay, so this is a really long video, but I hope you see the value of the ALINEAR program. I cannot make it any more clear than I have, or clearer than it is. This is a valuable program for the SAT because there are so many linear equations and so many linear functions and so many proportions on the exam. So here, if you want to get a copy of the ALINEAR program, 3 things. Send me your email, subscribe to my channel, and if you would like this video, I would appreciate it. Also, put on your notification because I'm going to be putting out some more videos in the next couple of days, and I'm going to be showing you a couple more programs that I think that you might want to have on your calculator. But that's it. I hope that you see how valuable ALINEAR is. All right, guys. You're going to see my subscription notification. Please subscribe, send your email, and I will get you this program as soon as possible. Thank you for all of your support, and stay safe, and good luck.